Okay, next, I want to look at a really fun one. Go back to my list, and what I'm looking for here, you ready? Max features. This is cool. And you'll see that XGBoost has a lot of like these types of options. So the number of features to consider when looking for the best split. Now, what does that mean? Okay, so first of all, what's a feature? A feature is like a column. It's sometimes called an attribute. So it's different columns. It says number to consider when looking for the best split. So if I go back to my data, okay, and I look at it, here it is. So generally speaking, when it's looking like, okay, I want to try to split the data and I want to find the best way of splitting it. That's what decision trees do. They split the data a bunch of time. It's considering every column, okay? Now, this has a respectable number of columns. I can't tell how many just looking at it, but we could easily find out. I mean, here, let me show you df.shape. If you don't know that, gives you the shape of your data. It's an attribute, so there's no parentheses. So it shows 303 rows and 14 columns. Note 13 are actually for X. So the idea is that, again, so it's the optimization of this model is finding the best splits. Max features says, you know what? What if we don't consider all the splits? What if we just consider a percentage of them? Okay, so I go up here and it says that the default is none, so it considers them all. And by the way, it gives you, what's interesting is it gives you some different options here. It says, by the way, look, these are interesting possibilities, and they're interesting in particular when you're looking at like large data sets, but you can literally just put in percentages. Okay, that's what these are. Like n features for us would be 13. So what's the square root of n features? What's the square root of 13? Well, 4 squared is 16, so it's going to be like 3 or 4, because 3 squared is 9. But you can actually put in anything, and I can double check, but I believe you can just, yeah, you can just put in percentages. So you don't have to do it based on the number of max features. Wait, I'm sorry. Yeah, yeah. You can just put in percentages, which is what I like to do. And the reason why I put in percentages and not like the number, like based on the number of features, is because percentages would be valid for any data set. Okay, so let me show you what I mean. And let's start just by doing this one also on its own, and then we'll do it with the others. All right. Copy and encode, and then change it to max features. Like get rid of, well, you know, copy in too much, you got to cut more. All right. So max features is the name of it. And so what are some interesting amounts to try? Well, one would be like the norm. Okay, it's good to have something like that in there. Well, I'll just count like down from 0.9, 0.8. So 0.8 means, hey, we're only going to consider 80% of the splits. 0.7, 0.6, 0.5, 0.4. One other thing, by the way, it's always worth noting that when you're looking at these, like it's worth knowing. So if you're only considering 40% of the columns, it's going to build faster because it's not checking all the columns. Okay, I'm going to put in 0.3 too. All right. So again, not considering all the columns, and you may wonder, well, wait a minute, how do we know which columns it's picking? I think it's actually random. And again, we can get more information looking here. I mean, it should be random. The reason why I say this is because how would it know like which ones to select and not to select? Because if it's only considering, a certain amount. And by the way, random state can, that's another thing that can be used. I don't usually use that. We can do it to match code and to look at particular cases because I think it's kind of fun when you get something different. Okay, so let's just run it and see what happens. So we got, nothing like spectacular in itself, right? We got a little better considering, just 90% of the data. Let us try this with the others. I also want to see, so we got 76%. Let's just keep going. I want to make sure that the 1 is in fact, what is the default? It says, hold on. Just want to double check something. Default is none. Okay, so it says none. So let's make sure that that's 1 is working as none. Because one could actually be interpreted as, right, because you can put in max features equals 3 as 1 only. So let's check that. No to give a different score, but same result. Okay. Well, let's try with the others. I can tell you that these limiting numbers of columns can give you like really interesting results. I don't know that it will here. I just mentioned that for future reference. Okay, so we had a nice little search here of some key kind of key results. We got our best score out of this group. And in particular, I want to look at what we got it from. We got it from max depth of 4 and min samples leaf is 16. I'm going to use that to help us limit the range. Okay, you'll see why in a minute. And so for 4, let's go with, we haven't seen 2 yet. Maybe something like this. So that's 3 to the third. That's 27 models right there. And so the question is, well, how many, right? How many max features are we going to try? Like, small data set, it shouldn't take too long. Well, we started by getting some good results with some high ones. So let's just, we got to go with none because that's guaranteed that we have the previous best score in there. But now let's try this, maybe some of the higher ones like 0.9, 0.8. And you can also kind of like push, you don't have to count by ones, or you can say, well, I want to force it a little more. Like, what if I do this? Okay, and I think that's a reasonable grid search. Let's do it. And we did not improve the results. Okay, let's see if we can improve it. All right. And note that min samples leaf, see something, it's doing it a little different each time. I can show you how to guarantee to get the same at some point. We haven't tried 15. Have fun with it. Okay, we got the max depth was also 3. So right, max depth of 4, min sample 16, a little trade-off there. Let's try that. We got the 0.9. Let's try 0.8. Okay, so let's just try that. Let's see if we get anything. And note that it's interesting that we get, so max features is not like, cutting it down is not improving it in this case. And the reason why is because we only have so many columns and so many rows. When you have a ton of columns, it's actually really nice. And even if you have a lot of rows, it can really help you to generalize. So that happens a lot. It's like, hey, they have pretty good defaults, and it's in some cases, you'll see this too with XGBoost, it's hard to beat the defaults with some of the models. So for me, I feel confident saying, you know what? Max features isn't giving us any gain. We can leave that one behind and move on to a different one.